My name is Luke Westervelt. I'm a student at the Harvard Extension School, and for my final project I created a C command line program called Substitution Cipher Solver. And what this program does is it solves substitution ciphers or Caesar ciphers without the key. So if you remember from problem set 2, a Caesar cipher is basically a scrambled message is created by mixing up the alphabet. So I have a website here that lets me create different messages and change the key here for the message. So I've entered the plain text here, gregarious gorillas, and I've gotten the encoded message here. So normally if you just had the code without the actual message, it would be pretty difficult to solve this, but with this program, if I enter it here, it's able to immediately decode it. So down here you can see it has both of the words with a number next to it. This is for in cases where it's not able to 100% solve the message. It instead displays possible solutions down here, and if the word that is a possible solution is within the top 10,000 most commonly used English words, it will display the number next to that word. So in cases where it shows 0, that means it's not within the top 10,000. So I'll show another example, this one with a more complex sentence. So I've pulled up a couple of news articles that were published today just as an example. So I'll pull this sentence and encode it. And the program right now does not handle punctuation, so I just need to remove any periods, commas, etc. And I'll scramble the cipher a little bit just for demonstration purposes. So run it again, enter the sentence, and it's able to decode the sentence. So you can see here the sentence, countries neighboring India such as Nepal are also seeing surges of the virus, and that is exactly what the sentence is. So it's able to decode that sentence just with taking the scrambled message as input. And down here you can see so there are some cases where there are other words that could possibly be a solution for this sentence. So like Nepal could be Naral instead. So this is what I was mentioning before, where it shows if that word is within the top 10,000 words that are commonly used in the English language or not. If it is, then it's probably more likely to be the correct solution. In this case, it doesn't really matter because it was able to decode the encoded message correctly right off the bat, so we don't even need to look at this. But if I can find another sentence, I'll just open a news article and pull a sentence from here. There's a chance that it won't be able to decode the message 100%, and we might have to use some of the suggested solutions instead. So let's see, just trying to find a good sentence. So again, you just have to remove the punctuation. And let's see. Okay, so here's an example when it wasn't able to decode the sentence 100%. So here, the sentence is long before the vaccine became available, many countries tried to curb the spread of the virus. But when I enter the coded message, instead I get lone instead of long, main instead of many, and I think everything else is correct. But if we scroll down here, we can see that there long, which is the correct word, is proposed as a possible solution instead of lone. So even though it was not able to decode that message with 100% accuracy, it was able to get very close, and it does provide the correct words down here. So yeah, that's basically how the program works.